multiple choice. If you haven't finished, that's okay, just keep going. But we'll just go through the first 10. Most of you guys seem to have finished it within, I would say, about 15 minutes. So that's really, really good. Very reassuring on your part. All right, first question. The answer is C. The reason why is you're looking for which is false. So which one doesn't make sense. If you read through all of them, the only one that won't make sense is C. So, for example, in A, it says the average temperature peaks in July. Well, if you look at July, that's the maximum there. So that's a true statement. So it can't be that. There is an increasing trend in the first half of the year and a decreasing trend in the second half of the year. Well, you could say that might be the case. Okay, but again, it's not always consistent. Okay, because then you might be looking at later part of the year. But again, it might not be the. Actually, no, that is true. What am I talking about? We're looking at the false statements. C, the recorded average temperature exceeds 20 for the first half of the year. Well, if you look at the first half of the year, that would be up to June. Okay, the highest already there is 24. Okay, so that means this is saying which one is false? Well, this one. And the other ones are also true. So we'll leave it at that. Question 2, share prices. So you're looking at the share prices for these two shops. The approximate end of the year share price for Big T and Wargate in 01. So you're looking at 01. So if that's 2000, 01 would be here. So you're looking at these numbers. Okay, I know some of you may have picked B because it's 14 and 17, but just watch for the order that it says. It's Big T and Wargate. So it's got to be the blue line and then the red line. Question 3, the correlation between the two variables is strong negative. Okay, you could have said moderate, but there's no moderate here. So it's either strong or weak, and it's either positive or negative. So it's going down, so it's definitely negative, and it's also going to be strong. Okay. All right, let's keep going. Scatter plot below, which is the outlier here? Well, the most likely outliers. Now, this is to throw you off here, but the most likely outlier is only that one there. Okay, you could say that this might be an outlier, but because it sort of follows the rest of the data, it might not be. Okay, so the most likely outlier is probably that one there. So that would be 16.8 for that coordinate. 16.8 because it's 16.8. All right, next one. Question 5. Question 5. What is the solution to this? What's x? X is 28. So you can look at my working out there, but you can watch me do it here as well. If you're confused about how to do these questions, I always like to write the question again and then work it out. And then from there, use inverse operations. So try get rid of that 15 first. It's a minus 15. So you want a plus 15 to get rid of it. So that's gone now. So you get 2x equals 41 plus 15 is 56. And then that's 2 times. So if you want to get rid of it, you have to divide it and then divide it. So that means x is equal to 28. All right, easy. All right, next one, same thing, but before you actually start solving, you have to expand the brackets. So when you expand the brackets, it's good to, again, rewrite the question and just follow this format. So this is what I like to do. I rewrite the question, okay, equals 30, and then I sort of just follow the sequence. I try to keep it the same, like as in, you know, you've got your equations here, and then there's an equal sign, and then there's an answer in the end. Put it in like the similar thing so it's really organized. So 5 times 3 first, work that out, equals 15x. Okay, and the next one is 5 times negative 8, which equals negative, sorry, that should be 6, not 8. 30 equals 30. Okay, and solving that, again, when you get a question like this, get rid of that number by itself first. So it's minus 30, you're going to add 30 to get rid of it. So you're left with 15x equals 60. Okay, this is a divide 15 times, so you got to divide it to get rid of it. So it's divided by 15, therefore x equals 4. Okay, next one. This one, some of you might get a little bit confused, yeah, but understand, okay, what's the gradient and what's the y-intercept? So I can see the y-intercept here is 10. Okay, so for, actually, at least for this equation, the y-intercept is 10. And the gradient is negative -1 over 2. So what this is telling you is the y-intercept is going to be at 10, and your line has to go downwards. It's going to be negative. So if you look at this already, look for a line with a y-intercept of 10. You could say it's this, but is the line going up or down? It's going up, so it can't be that one. Okay, because my gradient is a negative. Let's look at B. Okay, the y-intercept here is -20, so it can't be that. We're looking for a y-intercept of 10. C has a y-intercept of 10, and it's got a negative gradient, and you can test the gradient as well with the points, but that's the only logical one, because D has a y-intercept of 20, so that wouldn't make sense either. So it has to be C. Has to be. Alright, question 8. The gradient represented in the following equation. So what's the gradient here? Remember, the gradient is the number that's paired with the x. So it's always with the x there. So the gradient is -2. Okay. -2 for the gradient. Also remember, if you're asked to draw the line, if you have a gradient of, that's a whole number, just put it over 1. If it's a fraction, that's already the rise over run. Alright. Question 9, an experiment was conducted by the engineer. A prediction was made, the force of 15 is an example of. So you're trying to tell me, if you have all this data here and you make a prediction for 15, look at the range of data. Is 15 interpolation, extrapolation, rise and run, correlation, or none of the above? Because you're making a prediction, it's going to have to be either interpolation or extrapolation. Remember, if it's in the range, so if you look at the range of the data here, I can see that it's in 15 is between 1 and 20, so it's got to be in that box somewhere if you try to visualize it. So that means it's interpolation. Okay, it's in the range of 1 to 20. Okay, last one. Okay, this one was a bit tricky because the line of best fit is drawn, and you have to look for 2 coordinates that work in the data to find the equation. So what I did was I went through each of the answers and I looked for it in the data. You have to make sure that the coordinates all fall in the line. So if you look at this one, 5, 4, well, 5, 4 is over here. It doesn't fall in the line, so it can't be this one. Okay, 14, 15 for this one. Yes, 14, 15 falls on the line right there, but again, 5, 4 doesn't fall in the line, so it's not that. Look at the next one, 20, 21. So if you get 20, 21, okay, that's a good one. 15, 15, 15, 15 is over here. That one doesn't fall on the line. Okay, so that one won't work. The only one that where both coordinates fall on the line is D, 5, 6. So if you go 5, 6, that's over here. And then 3, 13, 14, so 13, 14 right there. You have to make sure that the coordinates are on that line if you want to find the equation for the line of best fit. Cool, that's it. All right, keep going. Do the short. So the first 2 questions of the short answer. Now, I found this graph was a little bit tricky to read because of the information that it says there, but don't get too scared or frazzled by what it's talking about, okay? Main thing is, you have a graph here. Okay, you've got your graph. It's Australian population, and some of the numbers are recorded throughout the years, okay? And it's saying it's recorded from 1788 to 2006. Cool. All right. And also it says here prior to 61, so 1961 would be like about here somewhere, I think. Okay. It does not include the Aboriginal population. So just before that, it doesn't include the population of Aboriginals. Okay. So let's first talk about the trend. Now, in terms of the trend, you don't have to have the same answer as me, but the things that I was looking for, okay, is at least talk about how, over here was 0, and then there's an increasing trend at some point, okay? You don't even have to talk, actually increasing trend, talk about the specific years, but what I'm looking for specifically is the trend. So I want to see at least this word. If you included increasing trend in your answer, I would give you the mark. If you wrote increase from a certain year, then I would give it to you. But I think in year 11, what they look for is this word, increasing trend, decreasing trend. That's it. So you have to include at least those 2 words. Okay, I'm going to go a bit ahead. Some of you might be wondering, didn't get this second question. Why does the graph seem to go along the horizontal axis for the first 50 years or so? So here, first 50 years around here, you could, obviously, the answer, they said that the population is 0. And that would be because, that's not true though, because obviously there's people already living there, so the population can't be 0. So the only logical answer is just they weren't recording the numbers at that point. So they weren't recording numbers for population then. Does that make sense? You got to think about it a little bit outside the box. Yeah. You could also say that, and if you did that, I would say yes. But I guess in the context of the whole thing, that maybe they hadn't found the Aboriginals. Well, I don't know. I wasn't there back then, so. But I think because they put a population of 0, they weren't counting populations at all at that point. Obviously, they're settled there, so that means there would be a population, right? But they just weren't counting it. But you could also say that, I guess. I would say, because this question is a bit tricky, so. The next one is even trickier. Which year does the population grow the greatest increase? So, to understand the greatest increase, you've got to look for the most steep line in here. All right, so I, in my opinion, although this question was a bit crazy, the most steep line is here. This line right there. It's got the most steep line. Steep meaning greatest gradient. Because, say for example, which has more growth? A line that goes like this or a line that goes like that? Okay, the line that has the bigger gradient is the most, obviously, biggest growth. And that was here. Now, the year there was a bit subjective. But if you wrote for your answer, and I'll give you a mark somewhere between 1960 and 1980, a year in between there somewhere, I would give you the answer for it. Okay, so I'll be a bit lenient there. So if your answer was somewhere in between those years, you get the mark. What did you guys write for that, or did anyone not get that? Not really? Yeah, okay, fair enough. Yes? 50 to 2000? It does say which year, not years. So he wants a specific year, but Dylan, I'll give it to you. Okay, because it's a confusing question. So you're correct in saying that this has the biggest growth right there, that sort of bracket in time. All right, let's keep going. Time series for here, so it's the car value over time. So the value of the car at the start there, and it'll decrease over time to the point here in 10 years. Okay, so cool. All right, first question is, what is the value of the car when it's new? 25,000, okay? When the car is new, which means 0, the beginning, y-intercept, 25,000. How old is the car when it is valued at 15,000? Okay, I wrote 4 or a little bit over 4 years. So if you look at 15,000, which is here, the age of a car is about 4 years, so here. Okay, and now I wrote a little bit over 4 because technically 15,000 is like over here. So it's just a bit over 4 years if you think about it. But if you wrote 4, that's correct. Do you guys get 4? Yeah, good. Okay. This one is tricky. How many years do you predict the value of the car to fall below 5,000 or 5,000? Now, that one was hard because it does go outside of the graph. Okay? But if you just follow, I sort of just followed the line. You can draw a little bit ahead of it if you want to. And you can kind of, make a prediction there. But let's say that's, I would say that's 11 years. Oh, it could be, all right, 12 years, didn't I? Yeah, I would say 11 is probably more accurate. Because, kind of hard to say, but, right there, probably there. That would make more sense to be 11. Yeah. Did you have your hand up, Ramia?
I did talk to person.
Okay.
I was just kind of guessing.
Yeah, I was guessing as well. I was guessing that the line would curve a bit like that, maybe. But, here or there. Okay. If you're at 11, actually, if you're at 11 or 12, I would give you that. Okay, comment on the trend of the graph. So again, the main thing I want to see is this word, decreasing trend. If you wrote that somewhere in your answer, correct. Okay, you can have a bunch of other things in there, but at least if you put decreasing trend, that's the main thing.
I said negative decline.
Alright, I'll give it to you. But in year 11, please be specific with writing decreasing trend, because that's what they look for.
Would you want like the Steady.
Yeah, you could say steady decreasing trend, but we just want to know that you can understand if it's a negative decrease trend, increase trend, or if it's like this. What would that mean, guys? If you're just up and down, there'd be no trend, no trend. If it's just random, like it just goes up and down like that. Okay, no trend. All right, that is for question 2. Have you guys done question 3?
Yeah.
All right, let's go through question 3. Okay, let's do this one. Did I tell you it was 2y? Oh, sorry, it's 2 over y. Okay, I'll show how I work this out. So you've got 18xz over 9xyz. Okay, so here what happens is the 18 and the 9, they get cancelled out and they become 2 because they're both divisible by 9. That becomes 1, that becomes 2. Okay, cool. The x and the x cancel each other out, and the z and the z cancel each other out. So the answer you're left with is 2 over 1y. But you don't need that 1 anymore because it's the invisible 1, so it's just 2 over y.
Wait, what did you say it was invisible what?
The 1. Because you don't need that 1, like there's no point in putting...
18 and 9, what was it?
Oh, 9. They can divide both by 9. Okay. Alright, cool. If you're... I think one way you can sort of work this out on your calculator... sorry, you can just copy that there. But on your calculator, if you're confused about... like you say if you got a fraction and you wanted like 18 over 9... If you just ignore all of the letters for now, and you just have 18 over 9, if you put it on your calculator, they'll actually give you the answer. So if you go fraction 18 over 9, okay, it's 2. Gives you that. Also, let's say for example you get like 15 over 20. Let's go 15 over 25.
Would your working out be okay, mate?
No, actually, most of the questions in the SAC will just be like this, 1 mark questions, which means you just need to show your answer. So if you did that, there's your answer, 3 over 5. And you just got to cancel out the letters. Okay, let's get rid of this. Okay, cool. All right, let's go to question 3b. Expand this. So basically, this is just multiplying the numbers on the outside with the numbers inside. So 3 times 5 is 15x there. And then 3 times negative 3y is negative 9y.
I think one step after that too.
Which is
6xy.
incorrect. This is the final answer. Okay, you can't. There's no like terms. You can't put x and y together. They have to be exactly the same. So, Lily, you can give yourself 1 mark for that. Just don't do the extra step. All right, next one. Solve to find x. X equals 40. For the answer. Anyone else not get 40? Okay, do we understand how to get 40 from this? Yeah. And for the last one, x equals 4. Oh, this is question 4. I'll do E. There's a lot of working out there. It's a bit crazy. I'll just go back up. Sorry, yep. So if you want, I can do this step by step if you want. So 2x plus 5 equals 85. Get rid of that 5 first. It's a plus 5, so it becomes minus. So you get 2x equals 80. That's 2 times 8. 2 times. So it's divided by 2. Therefore, x is 40 for that one. You can do the next one too. Okay, so that's 7x plus 2 over 5 equals 6. You want to get rid of that 5 first on the bottom. So it's divided by 5, so it becomes times 5. So you get 7x plus 2 equals 30. Okay, and then from there, get rid of that plus 2. Okay, it's plus 2, so it becomes minus 2 here. 7x equals 30 minus 2 is 28. This is 7 times x, so it's a times 7. Becomes divided by 7, x equals 4. Alright, now the next one is a bit tricky because there's a lot involved in there. And if you want, you don't have to fully copy this. I'm going to rewrite it. Oh, are you still copying? Sorry. I can rewrite this so you guys can see how it's done. Okay, so you can follow me as I go. As it's a bit harder to do it if you just look at the writing. Alright, so again with these questions, what you want to do is you need to expand the brackets first. So multiply everything on the outside with the inside. So in this case, 10 times 3 is 30x. And then 10 times minus 9 is minus 90. I'll use different colors. Okay, next is this minus 2 times 3 is minus 6. So it's now this number times everything in here. And then minus 2 times 4 is negative 8x, so minus 8x. Remember, if you multiply a negative with a positive, it becomes negative, like this one. Equals, okay, next one. 6 times 2 is 12x. So I've done this one basically. 6 times 2x. And then 6 times negative 2 is negative 12. Okay, and then from there, it gets a bit tricky because now you have to put all of the letters together and the numbers together. So that means I need to move this 12x here. Okay, and I need to move these two numbers over here. Before I do that, I can put like terms together. So what that means is in here, okay, this number and this number are like terms because they both have an x in it. So 30x, oh, sorry guys, why does it keep doing that? 30x, I'll rewrite it for you guys, minus 8x can be put together. Okay, and the other terms that are the same are this minus 9 and minus 6. So minus 9, and I'm only doing this so it's easier to see what's happened. Okay, you can see, okay, that I've put the terms together, or I've arranged them together so they're easier to look at. So you can evaluate that. Okay, 30x minus 8x is 22x. Oh my goodness. Why does it do that? Okay. Sorry. 30x minus 8x is 22x. Okay, and then negative 9 minus 6, I'll just leave it the same color, is, okay, anyone know how to add negatives together? Did I say 90? Oh, I'm so sorry. Where did I get 90 from? My bad. Yeah, I didn't write my extra 0. Oh no. Thank you for catching me out on that. So that should be 90. Oh my gosh. Okay, cool. And then negative 90. Thank you for that, Kyla. So negative 90 minus 6 is negative 96. Okay, and then again, you've got equals 12x minus 12. Alright, so now from there, the next thing is to put the letters together and the numbers together. So I want to move this 12x over here. Okay, and I want to move this 96 on the other side. So I'm moving that guy here, and I'm moving this guy over here. So they're just swapping sides because, again, you want to put the letters and numbers together. If you move this 96 on the other side, it's negative. So it'll become positive. So if you put this here, this gets a bit tricky. That becomes minus 96. Oh, sorry, plus 96. And then this 12x, if you bring it here, becomes minus 12x. Okay, so I'm going to get rid of all that. And I'm going to rewrite it. So it looks like this now. Putting it all together, you get 22x minus 12x. Oh my gosh. No, I've turned off the touch. I think I just need a new device. 22x minus 12x equals, okay, that 96 has been put here, so negative 12 plus 96. Okay, solving that you get 10x, okay, equals negative 12 plus 96, that is, what's that, 84? And then from there, get rid of that, that's 10. Okay, it's divided by here on the other side. Okay, so that means x equals 8.4. It's quite long, I know. That's a bit crazy. I think we can Yeah. Okay. Cool. Did anyone get that? No.
Maximum got to include
Yeah, it gets a bit crazy. All right, cool. I'm gonna stop at 4. We finished up with question 3 last time, so we're doing 4. Alright, so these ones can be a bit tricky because normally with a graph, normally it'll show you what the actual intercept is here, or what these lines are going to, where it intercepts the line, but in this case it doesn't. So what you've got to use is the coordinates. Okay, looking at the first one, look at the line. Okay, if it's vertical like that, if you get a line like this, the equation is going to be x equals something. And you just got to figure out what intercept is it here on the x-axis. Anyone know what it is and why? Anyone know? It's 2. Why is it 2? Okay, although they both have 2, yes, but if you look at the coordinate, apparently this is 2, 2, and that's 2, negative 1. So what that's saying is that to get to this coordinate, it's 2, for example, the top one 2, then up 2. Okay, that's that coordinate. And for this one, it'll be go across 2 and then go down 1. So technically, this point here is 2 on the x-axis. So that means the formula is x equals 2. Now, normally, like I said, it will tell you the actual line there, or where it crosses the line, but because these ones are tricky, you've got to go that extra step. Now, the next one, if you get a line that's horizontal like this, okay, it's going to be a y equals type of equation. In this case, figure out what this is by looking at the coordinates. So according to this coordinate here, okay, it's negative 2, 3, so 1, 2, and then you go up 3, 1, 2, 3, okay, that's that. And this is 3, 3, so that means it's 1, 2, 3, and then you go up 2, 3, up there. That means that line, okay, here, this spot, must be the 3. Okay, another way you can look at it is, you can look at also the coordinates there. So you can see there, because they're both 3 on the y, okay, that means the y-intercept is 3. And for this one, because both of the x's are 2, the x-intercept is 2. Okay, let's go to the next one. These ones. A line passes through 5, 5, and 8, 14. Find the gradient. All right, I'll rewrite this again. Actually, no, I won't. But for finding the gradient, okay, remember you got to have 2 points to do this. Okay, I'm going to start this all over again so you can see. Remember as well, this is the formula for your gradient there. So what you want to do is with the points, let's zoom in a bit, or you need to label them x1, y1, and then x2, y2, and then use that formula to figure it out. So just substitute your values in the formula. So y2 is 14, I can see there. y1 is 5. x2 is 8. And then x1 is 5 there. So working that out, 14 take away 5 is 9. 8 take away 5 is 3. Okay, so that means the gradient, in this case, simplifying that will be just 3. Okay, so there's my gradient. Nice and easy. Next is find the y-intercept. So now here you've got the gradient. You've got a couple of points. So what you need to do now is get your formula of y equals mx plus c. And you need to substitute the gradient and any of these points. You can pick either or. In this case, I picked this point here. So remember that's x, that's y. So change x to 14 and x to 8 and y to 14. So my formula, y is going to be 14. My gradient, remember, was 3. So 3. And then my x is going to be 8 because I'm using this coordinate. So 8 and then plus c. Solving that. So 8 times 3 should be, I've worked it out here. Actually, let me do this here for you guys. Okay. I'll start this over again so you can see. All right, so we're at this point. So you got 14 equals evaluate 3 times 8, which is 24 plus c. So going up here now. From here, Okay, I want to move that 24 to the other side, so it becomes minus 24. So you get 14, take away 24, equals C. Evaluating that, actually I just put it here, 14 take away 24 equals C. So that means C should be minus 10, because 14 take away 24 equals minus 10. Alright, and then finally, state the equation. So you've got your gradient, which is 3. You've got your y-intercept, which is minus 10. And then just put that in your equation. Remember, the equation is y equals mx plus c. So you're only changing the gradient and the y-intercept. Those two things. Did anyone get up to question 6?
Yeah.
Yep. Alright, let's do question 6 then real quick. And then we'll be done very soon. Alright, question 6. Sorry, people still copying. Copy it down. Please do so. But remember, this will also be on OneNote and or Teams. And I'm putting the video together today so you can watch it at home tonight for the SAC tomorrow. Alright, let's move on. Next one, question 6. An egg timer contains grains of sand which pour through the neck of the timer from the top bulb to the bottom in 3 minutes. Right, so basically what this is saying is you've got an egg timer and it takes 3 minutes for it to drain from one side to the other. And you can see here on this graph, at the beginning, or at 0, okay, you've got 48,000 or 4,800 grains of sand, and then at 3 minutes, you've got nothing left, okay? So question is, how many grains of sand are in the egg timer? This is saying how much at the start or how much altogether at the beginning, okay? Which obviously should be, at the start, you've got 4,800 bulbs of sand. Sorry, grains of sand. That's pretty easy. Okay, next one is find the gradient by identifying 2 points that the line passes through. Okay, the 2 points that you can use are the intercepts. Okay, I've got here point number 1, or one of the points is 0, 4,800. That's 1 point. The other point, which is this one, is 3, 0. Okay, did anyone use those points or when you got to this question? Those are the 2 points that you can use.
I used them for 8,000.
For 8,000?
Yeah, like 408,000.
400. This.
4,800, sorry.
This one.
Yeah, I used that one, I didn't use the 3.
What did you use for the other one?
Just like 2.5.
2.5 and then 800.
Yeah.
Did it work? We'll see.
I don't think so.
We will see. So I will do this all over again so you can see the answer. All right. See, here are the 2 points. You want to make sure you write your 2 points first, yeah? And then you label it x1, y1, x2, y2. So there's my formula, y2 minus y1, x2 minus x1. And then just substitute it, okay? In this case, y2, oh, sorry, I did it the other way around, I think. Oh, no, sorry. y2 minus y1, I did it right. So 0, take away 4,800, divided by x2 minus x1, which is 3 minus 0. Okay, put it in your calculator, evaluate. So there's my gradient. Did you get it right?
Yeah.
There you go. Easy. Okay, slope is the gradient.
I forgot how you do gradient.
I'm showing you right here now. Use this formula.
Oh, right.
Yep. But you got to have 2 points though.
What if you don't have 2 points?
Then you can't find the slope.
So if it's y equals negative 6 minus 2x.
Okay, guys, tell him what's the gradient there. Y equals?
Negative 6 minus 2x.
Okay, which one's the slope there? Y equals negative 6. I've got the formula.
Negative 6 is the gradient.
Not quite, no. Which one's the gradient?
Oh, the minus 2.
The minus 2, the one paired with the x, is the gradient. There's your answer.
So what do I do with that now?
Well, what's the rest of the question asking you?
The gradient of the line is represented by the equation is equal to.
There's your gradient, minus 2. Okay. Question C here. Determine the rule by connecting how many grains of sand are in the top bulb. Okay, this is easy. Okay, remember your formula is y equals mx plus c. There are 2 things you need to know. The gradient and the y-intercept. You've already got the y-intercept, 4,800 grams. Okay, and you've got your gradient right there. So put that in your formula. Y equals Okay, negative 1600x plus 4800. Now the next step to that is you just got to change two variables. You have to change x and y, okay, to whatever it is in the graph here. So that means time is x, and then sand is y, or grains of sand is y. Grains of sand is y. Sorry, I just repeated myself. So all you got to change is x and y. So remember, this was x, that was y. Just change it on, change the letters there for the formula. Okay, so there's your final formula and what it should look like. Just changing x and y to whatever it is on the graph. So if x was bananas and y was strawberries, then change that x and y. All right. And then the last question is, use your rule to determine how much grains of sand is left after 2 minutes. So in my formula, which is this one, I just got to change t to 2. Okay, which is what's happened here. All right, the answer is 1600. So after 2 minutes, yeah, the number of sand, grains of sand should be 1600 left. All right, I'm going to take a pause there. Let's do it. Hutton,
Yes.
you're in the video. Be quiet.
Oh, sorry.
All right. So this last question here is: you've got a company that investigates whether the outside temp is related to the number of people who prefer spending time in a recreation room. Oh no, this is a crazy question. All right. Temperature, if that has anything to do with people wanting to stay indoors, basically. Okay. So obviously, as you can see, okay, looking at the graph, the hotter the temperature is, okay, the less people are in the room, okay, or the lower the number of people in the room, okay, because obviously if you stay indoors, it might get too hot. That's what this graph is saying at least, right? So you can see if the temperature is low, there's more people inside the room, and if the temperature is high, there's less people in the room. That's the trend from what I can see. First question is describe the correlation. A couple things I am looking for here is you're talking about, remember, correlation. What's the strength? What's the direction? Those are the two things you got to talk about. Strength, according to this, I would say is moderate. Did anyone put moderate?
Yeah.
Yep, probably more moderate. If it was strong, I think the line, the dots would probably make a really obvious line. If it was weak, it'd be a lot more scattered. So I would say that's moderate. And then you got to talk about the direction. Is it positive or negative? The dots are going downwards, so it must be negative. Okay, so two things I'm looking for. Moderate, so the strength and the direction. You don't have to have everything else on this. The main thing is you have to talk about the strength and direction. Okay, those two things at least. If you put these, I don't mind, but this is what we expect in year 11. So you got to include all of this in year 11, but you're year 10, so it doesn't matter. Strength, direction. All right, next one. Draw a line of best fit. Everyone's line is going to look different. Okay, but as long as your line looks something like that, make sure your line, okay, does not look something like this. Don't draw a line like this, or like that, or some other line like that. It has to follow the dots. Okay, and you want to make sure that generally you don't have to make the line start at the axis. If you can, that'll be good, but if not, that's okay. But what you can see is I did make the line go all the way, at least, to the y-intercept there. So you don't have to, but I like to do that. Okay, just a good habit. In year 11, you don't really have to draw a line of best fit because the calculator will do it for you. All right, let's move on. Now we use the line of best fit to make predictions. Okay, so make a prediction for the temperature outside when there are 22 people in the room. So if there's 22 people in the room, that's probably around here somewhere. So if that's 25, 22, must be here somewhere. So 22, if you said, so according to this for me, I would say the answer is 30 degrees. But if your answer is somewhere between 28 and 32, then you get a mark for it. Okay, because again, your line might be a bit different. Anyone get a different answer? Anywhere between 28 and 32, is that what we put? Good. Okay, that's what we want. Okay, next one. If temperature is 17, how many people in the room? So let's look at 17. 17, so if that's 20, 17 is probably about here somewhere. So going up, whoops, if I can draw a straight line, 17 is about here. Okay, so I would say that's like I don't know, 42 maybe. So if your answer is between 40 and 44, I would give you the mark for it. Okay? So again, it might vary based on your line. It changes for every person. Last question there. The number of people in the room when the outside temp is 50 degrees. So if it's 50 degrees, sorry guys, real quickly, I can see already, if you just follow the line, 50 is going to be here. Okay? But if you look at the line, it's already hit 0 at like even before 50. So if you went and said, 50, you'll have like negative 10 people. Technically, that'd be incorrect because you can't have negative people in the room. The lowest number you can have is 0. Okay, so realistically, if it's 50 degrees, there shouldn't be anyone in the room. 0. All right, did anyone write something else? No? No? Okay, cool. All right, so that's basically